third chapter of Maths first. Okay, that is Arithmetic Progression. Dear friends, in your childhood, you might have studied such a kind of pattern: flower, leaf, flower, leaf. Okay, so from lower class, you have studied such a kind of pattern. Okay, if I will ask you, after this leaf, what will be there? So obviously, the answer will be flower. Okay, because flower is falling to leaf. Okay, and you follow same method here to get the figure here. Okay, then next, this also when you started your class in the childhood. So first you have studied the numbers like 1, 2, 3, 4, 5. And obviously what will be here? 6, 7, 8. Then let's come to here. 5, 10, 15, 20, 25. Okay. That is nothing but the table of 5. After studying this 1 to 100 number, then you started your tables. Okay. So here if I will ask, the answer will be 30, 35 and so on. Let's come to here. Next one is 3, 0, 3, 0, 3, 0, 3, 0. And here, if I ask you, what will be the next number here? Okay, 9, 12, 19, 21, 23. Okay, so here it is quite difficult to give the answer, which number will be. So here, to give the answer of this, first you study what is the relation between these consecutive numbers, and same relation you try to follow for the next one. But here, now for your example here, each number is increased by 1. Okay, so 1 plus 1, 2, 2 plus 1, 3 and so on. Here 5 plus 5, 10, 10 plus 5, 15 and so on. Here there is a pattern 3, 0, 3, 0. These are alternate. But here after 9 you are getting 12 by adding 3. Then after 12 you are getting the 19 by adding 7. Okay. Then here by adding 2. Then here again 2. So here this first added 3, then 7. So here it is not a constant. Okay. So you are unable to give the answer of this. So dear friends, this is first these are the example of sequences. Okay. So what is in my sequence? Sequence is the collection of numbers arranged in a definite order according to definite rule. Okay. So here each number has its fixed order. If you will change here, if you will write this 15 after 5, and here if you will write 25, and if you will change the place of this number like this. So here 5, 15, 25, 20, 10. Then if I will ask here, so here we are unable to give the answer because it is not in a pattern, it is not in a sequence. Because according to the definition of sequence, that is, it is a collection of number arranged in a definite order. It means each number has its fixed place. So that is the order. And according to definite rule. That rule is, now here, the rule is that each flower is followed by the leaf. This is the rule. Here, what is the rule? That is, each number get increased by 1. Here, what we have written first, so each number was increased by 5. Then here is a pattern. Okay, that is 3 is followed by 0, then like that. Then here, such a pattern is not there, such a rule is not there. That's why it is not a sequence. Okay, so the sequence is a collection of number arranged in a definite order according to a definite rule. Okay, let's watch this video.
Take a look at this group of numbers. Do you see a pattern in the order they appear? Note that every subsequent number is 3 more than the previous number. Such a collection of numbers arranged in a definite order according to some definite rule is called a sequence. Let's now understand some notations and rules associated with sequences. Each number in the sequence is called a term of the sequence. The number in the first position is called the first term of the sequence and is denoted by T1. In this sequence, T1 is equal to 5. Similarly, the numbers in the second and third positions are called the second and third terms of the sequence respectively. The second term is denoted by T2 and the third is denoted by T3. In our sequence, T2 is equal to 8 and T3 is equal to 11. We can generalize this and understand that the number in the nth position of a sequence is called the nth term and is denoted by Tn. The sequence as a whole can be denoted like this. It is read as sequence Tn. What makes a sequence differ from a set is that the terms in a sequence are arranged in a specific order and cannot be rearranged. Also, unlike a set, in a sequence, a term may repeat itself as many times.
So dear friends, it's clear for you what is in my sequence and what are the terms. So each number in the sequence is called a term. The first number is called the first term denoted by T1, second number that we have seen through the middle. Okay. Now here, dear student, here these are the sequences. If you will observe the sequences, you will find that there is no fixed relationship between the any consecutive terms except this sequence. Okay. So for other sequences, you will find out the fixed relationship between the any two consecutive terms. Okay. So such types of sequences are called the progression. Progression is a special type of sequence, okay, in which there is a fixed relationship between the any two consecutive terms. There are three types of progression: arithmetic progression, geometric progression, and harmonic progression. Dear friends, this year in our 10th class, we are going to study only the arithmetic progression. So let's see what is in by arithmetic progression.
Disha is hosting a party at home. She's arranging chairs for a game of musical chairs. Let us see at what distance she has placed the chairs. She has placed the first chair 0.3 meters from the start line. The remaining chairs are placed at a distance of 0.7 meters, 1.1 meters, 1.5 meters and 1.9 meters from the start line. At what distance should she place the next chair? Notice that the placement of the chairs shows a pattern. Each chair is placed at a distance of 0.4 meters from each other. Thus, by adding 0.4 meters to 1.9 meters, we can find out where Disha should place the next chair. Such a series where the succeeding numbers can be obtained by adding or subtracting a fixed number is called an arithmetic progression.
So friends, from the video we came to know that to arrange the next chair, Disha has to add 0.4 to the preceding number. Okay, so here you can see these sequences 100, 90, 80, 70, 60. To get the next term, here we have to subtract the 10, or in other words we can say that we have to add negative 10. Similarly here 1, 2, 3, 4, 5, we have to add the 1 to the preceding term to get the next. Then here 5, 10, 15, 20, 25, here we have to add the 5 to each preceding term to get the next succeeding term. Now here 2, After 2, 4, 8, 16. So here we are getting the 4 by multiplying 2. Then here we are getting 8. 4 is multiplied by 2. Then 16, 8 is multiplied by 2. So 16 is multiplied by 2, we are getting 32. It means that here, to get the succeeding term, we have to multiply each term or preceding term by 2. So dear friends, these are the first 3 sequences, we can call it as the arithmetic progression. These are the first 3 sequences, we can call it as a arithmetic progression. Okay, so in the arithmetic progression is a sequence in which given a first term, the next term is obtained by adding a fixed number. This fixed number which we are adding is called the common difference, which is denoted by small d. So in this first 3 example, we are adding the number. Okay. So this negative 10, 1, 5, these are the values of this d. Okay. So this d, it can be positive or negative, or even it can be 0. Now here, this is not an arithmetic progression, because here we are getting the next term by multiplying 2 and not by adding. So this is not arithmetic progression. Okay. Now here, if we will say that negative 1, negative 1, negative 1, negative 1. This is also we can call it as the arithmetic progression, because here the number is added, that is 0. Okay. So negative 1 plus 0, that is negative 1. Okay. So in this case, we are adding the 0. So here we can say the value of d is 0. Okay. So the value of this common difference d, it can be positive, negative, or 0. So dear friends, we have seen what is meant by arithmetic progression. Okay. So here one more example we can see 5, 12, 19, 26. Let's say that whether it is an AP or not. Okay. So here we are getting the next term 12 by adding the 7 to the 5. We are getting 19 by adding 7 to 12. We are getting 26 by adding the 7 to the 19. It means that each succeeding term we are getting by adding the 7 to the preceding term. Okay. So here T1, that is first term is 5, second term T2 is 12, third term T3 is 19, T4 is 26. So here we can say it is an AP. So dear friends, in an AP, the first term is denoted by A and the common difference is denoted by 7. So here the value of A is 5 and D is equal to 7. Okay. So let's write down the sequence. Let's write down the AP in the form of A and D. So here the first term, that is A. Second term we are getting here A plus 7, that is D. So we can say that A plus D, then A plus 2D. Okay. Then to get the fourth term we can say A plus 3D. Okay. Now dear friends, if you want to find out any term, then how we can find out that? In the end, that last term will be divided by n. And if we want to show this Tn in the form of A and D, then how we can write? It's very simple. We can say that T1, that is first term, is A. T2, second term, that is A plus D. T3, third term, that is A plus 2D. Okay, it's very simple. You just see here, if you want to find out the second term, then we have to take the 1D. If you want to find out the third term, then we have to take the D 2 times, that is 2D. Similarly, if you want to find out the fourth term, then we can say that A plus 3D. You just observe this relation. Which term we want to find out? Just it's the one less we have to take with the D. Now if you want to find out T n, then this A is common for each term. Okay, so A plus, now preceding to this Tn, now here we don't know what is that difference, so we consider that D only. So we can say here T n minus 1. Okay, so here if you want to find out this Tn, then A plus, so here to get the Tn, what will do? A plus 1 less than n, that is n minus 1 into D. So by using this formula we can find out any term of an AP. So if we are knowing the first term and the common difference D, we are able to find out any term of that AP. Okay. So dear friends, now you came to know that how we can find out the any terms of an AP. Let's see the practice set 3.1. So our first question is, which of the following sequences are in AP? If they are AP, then find the common difference. Okay. So here we have to identify that whether the given sequence is an AP or not. So here I took the second example. So the terms in the sequence are 2, 5.2, 3, 7.2. Now we have to decide that whether it is an AP or not. For that, we will write here T1 is equal to 2, T2 is equal to 5 upon 2, T3 is equal to 3 and T4 is equal to 7 upon 4. Okay, so here as we have studied that if the difference between any two consecutive terms is a constant, then we can say it is an AP. So let's check that. For that we will do T2 minus T1. Dear students, always keep in mind, whenever we will find out the difference, it should be T2 minus T1. Whether our T2 is greater or smaller than T1, we did not have to mind that. Okay, so otherwise it should be T2 minus T1. So our T2 is 5 upon 2 minus T1, that is 2. So we have to do here subtraction, but the denominators are not same. So here we will make the denominators by multiplying this 2 by 2. So 2 2s are 4, that is 5 minus 4 upon 2, that is 1 upon 2. Similarly, we will find out T3 minus T2. T3 is 3 minus 5 upon 2. So here again we have to make the denominator same. That is 3 2s are 6 minus 5 upon 2, that is 1 upon 2. Then let's check for the T4. T4 minus T3, that is 7 upon 2 minus 3 is equal to, again here we have to multiply it by 2. So 7 minus 6 upon 2, that is 1 upon 2. So you can see here we are getting every time the difference as 1 upon 2, 1 upon 2, 1 upon 2. So we can say that the difference between any consecutive term is constant. That's why it is an AP. As we asked to write the value of D also, so here we can say that D is equal to 1 upon 2. Now let's come to the question number 2, in which you are given with the first term A and the common difference D. Then we asked to write the AP. So here, as we know that T1, that is first term, is nothing but A. So its value is 10. Then T2 is equal to A plus D, that is 10 plus 5. Value of D is 5. So 10 plus 5, 15. Then T3 is equal to A plus 2D, that is 10 plus 2 into bracket, value of D is 5. 2 5s are 10, that is 10 plus 10, 20. And T4 is equal to A plus 3D, that is 10 plus 3 into 5, that is 3 5s are 15, 15 plus 10, that is 25. So in this way, if we are given with the first term A and the common difference D, we can write the AP. So the required AP is 10 10, 15, 20, 25, dot dot dot. Now let's come to the next question. So question number 5. Find the 27th term of the following AP. So when AP is given, then how to find out the given term? Okay. So here the AP is 9, 4, negative 1, negative 6, negative 11. We have to find out the 27th term. So here T1, the first term is 9, second term is 4, third term is negative 1, fourth term is negative 6. So here it is mentioned that it is an AP. That's why we can say D is equal to T2 minus T1. Dear friends, always keep it in mind. When it is mentioned it is an AP, then only you can say T2 minus T1 is equal to D. So here you can say that D is equal to T2 minus T1, that is 4 minus 9, that is 5, and sign of bigger number, that is negative 5. Okay, so here we have the value of A as a 9, value of D as negative 5, N is 27 because we asked to find out the 27th term, that's why N is equal to 27 and T is 27 is equal to question mark. So we know the formula to find out any term, that is Tn is equal to A plus N minus 1 into D. Now in this formula, let's put the value. T27 is equal to 9 plus 27 minus 1 into D. The value of D is negative 5, that's why we will write it in the bracket. Then 9 plus, in a bracket 27 minus 1, that is 26 multiplied by negative 5. We are knowing that product of different sign is negative. So here we will get 26 5s are 130. Okay, so 9 minus 130, that is negative 121, sign of bigger number. So in this way 27th term is negative 121. Okay. Okay friends, so after this we have studied how to find out the any term of an AP. Okay, let's come to the next one. If you will ask to add the number from 1 to 20, okay, so you will take time to add the numbers from 1 to 20, that is 1 plus 2 plus 3 plus 4 plus up to 20 you have to add all the numbers. And if again you will ask to add the numbers from 1 to 50, then obviously you will take more time what you required for the 20, it's more time you will take for the 50. And again, if more than 50, if one will ask you to add the numbers from 1 to 100, so obviously we will take more time to get the sum. But dear friends, there was a boy who added these numbers in a few minutes. So I would like to tell you the story of a great German mathematician, that is Carl Gauss. So this is the story near about 300 years ago. There was a teacher and the teacher wanted to do some important work in the class. So students should keep the silence. So he given the work to his children that add the numbers from 1 to 100 so that the students will keep the silence. But this small child, Carl Gauss, within a few minutes he kept his slate down. The teacher asked him, "You don't want to do that?" Then he said that my work is completed. And he gave the answer, the sum of the numbers from 1 to 100 is 5050. So let's see what method he used to add these numbers. So you can see on the screen here Sn is equal to, he added first the numbers from 1 to 100. He wrote in this way, that is 1 plus 2 plus 3 plus 4 up to 100 he wrote. Then same numbers he wrote in the rewards, that is 100 plus 99 plus 98 plus 97, in this way up to 1. Then first sequence he said as a Sn and this also Sn. Then he added this number. Okay, so Sn plus Sn, that is 2Sn, and here 100 plus 1, that is 101, 99 plus 2 101. So in this way he added that, and every time he got the 101. So altogether he got 101 for 100 times. So here we can say that 2Sn is equal to 101 multiplied by 100. Okay, so we want to find out, he added it for 2 times. We want a sum only for 1 time. So this 2 is multiplied, it will divide. So we will get here 2 ones are 2, 2 50s are 100. So Sn is equal to 101 into 50. That is Sn is equal to 5050. So in this way he applied this method, and within a few minutes he gave the answer. Now dear students, we will see the formula how to find out the sum of the first n terms. Okay, so dear friends, we have seen what method is followed by the Carl-Lewis. Now let's find out the formula to find out the sum of first n terms of a given AP. Okay, so here our AP is, first term is A, then second term is A plus D, third is A plus 2D. Now we have to add all these terms, and our last term is the Tn. But here I made the changes, that is instead of Tn I wrote the L. L means our last term. Okay, so preceding to this L will be L minus D. Okay, so whatever is the common difference, so in the starting it will add, and if we are going reverse then we have to subtract the D, then before that L minus 2D. Okay, so it is in the form of 1 plus 2 plus 3 plus like 100. Then same thing how we added in the reverse, we'll add it in the reverse, that is L plus L minus D, then L minus 2D plus, then here A plus 2D, A plus D plus A. Okay, now let's add this both sequences. So Sn plus Sn, that is 2Sn, is equal to A plus L, then here A plus D plus L minus D. Now here positive negative D will cancel and we'll get A plus L. Similarly here A plus 2D plus L minus 2D. Again this 2D and positive 2D and negative 2D will cancel, we'll get A plus L. So if we'll go in this way, so every time we'll get the sum as A plus L, A plus L. Okay, so here 2Sn is equal to, now how many times we got the A plus L? As it is the nth term, so we can say n times we got the A plus L. So we'll multiply this A plus L by n. Okay, so we want to find out this sum only one time because we added it 2 times. So this 2, it is multiplying, it will divide, so n upon 2 is equal to A plus L. Okay, so this A is nothing but our first term, that is T1, and L is nothing but the last term. So in this way we can say that this is the formula to find out the sum of n terms, first n terms, if we are given with the first term and the last term. The formula is Sn is equal to n upon 2 into bracket T1 plus Tn. But if we are not given with the last term, instead of last term, if we are given with the first term and common difference, then how to find out? So we are knowing the formula, that is Tn is equal to A plus n minus 1 into D. So in the same formula we wrote the formula for Tn. So in the bracket we got A plus A, that is 2A plus n minus 1 into D. So dear students, here we got the formula. If we are given with the A and D, the formula to find out the first n sum of first n term is Sn is equal to n upon 2 into bracket 2A plus n minus 1 into D. So by using this formula we can find out the sum of first n terms.